Three-dimensional objects. We're starting off, we need to know what a three-dimensional object actually is. It is an object that has length, width, and height. So each one of those is its own dimension, so that's why there's 3 dimensions. You can describe a 3D object by its faces, which a face is a flat or curved surface. So this front piece of this shape is called a face. We have edges as well, which are the straight lines that join the different faces together. And then the vertex, or also called vertices, if you look at it over here, vertices is plural for vertex. That's the points that join the edges together. So edges join faces together, vertices join edges together. Write the name and number of edges, faces, and vertices for each object. So we're starting off here. This is called a rectangular prism. And it has front, back, top, bottom, left, and right sides. So there are 6 faces on there. And if you count the edges, there's 1, 2, 3, another one in the back is 4, and then we've got 4 on each end as well, for a total of 12 edges. And the vertices are the points, so we've got 1, 2, 3, 4 on this end, and another 4 on the other end, so there's a total of 8. Now on this shape, it's called a triangular prism. And it has, how many faces? It's got a front and back, so that's 2. This diagonal platform is 3. There's a rectangle along the bottom side there, which is 4, and then at the bottom of it is 5 faces in total. Edges, I've got 3 on the front, 3 on the back, so that's 6, 7 here, 8, and 9 on the side. So we have 9 edges in total. And vertices, we've got 3 in the front, 3 in the back, for a total of 6. Now, this next one is a bit of a special case. It is a rectangular prism, but because each face on this object is actually a square, it's a special case of a rectangular prism, and we call that a cube. But it has 6 faces, it has 12 edges, and it has 8 vertices, just like the rectangular prism. So there's some basic concepts about some fairly generic shapes that we may be working with. Next up, we're going to start talking about circles. Within the circle world, we have some definitions to deal with, including radius, which is the distance from the circle, from the center of the circle to the outside edge of the circle. So this line shown right here, that's called the radius, and it's usually indicated with the letter R. And something to note about the radius is that it is half the diameter. Diameter, which we're going to deal with next, is the distance all the way across the circle passing through the center. So if you think about it, there's a radius here, but then there's also a radius here. So 2 radiuses make up your diameter. And diameter is usually referenced using a D, a lowercase d. Now, so we've got radius there, we've got diameter here. We also have what's called the circumference. Circumference is kind of like the perimeter of a circle. It's the distance all the way around the outside of a circle. And for circumference, we usually use the letter C and a capital C to reference the circumference. Now there are formulas to be able to calculate that. And there are 2 formulas. One uses diameter, one uses radius, but they're 2 very related because diameter and radius are, one's double the size of the other or half the other. depending on which perspective you're looking at. So circumference, you can have it calculated as 2 times pi times r, and pi is approximately 3.14. Or you can use circumference is equal to pi times d. So pi times diameter, or pi times 2 times the radius. You can use either formula depending on what information you have been given. And lastly, as far as concepts go with circles, the area of a circle, it's the number of square units needed to cover a two-dimensional shape. That's what area is. And we usually use the letter A to reference area. And again, we do have a formula for that as well. Area for a circle is pi times the radius squared. Now radius squared means radius times radius. Radius times itself 2 times, that's what the 2 means. So pi times r, or pi times r squared. Usually, however, how you'll see it, and it has the exact same meaning. We just remove the times symbol and we just say area equals pi r squared. This means pi times radius squared. We just leave the multiplication sign out to simplify things. Just like actually up here, we could say that the circumference is equal to 2 pi r, or we could say that the circumference is equal to pi d. We don't need the multiplication signs in there with the formulas. So that's the world of circles. Next up on the get ready, find the circumference of each circle to the nearest tenth, which is 1 decimal place. So we've got our formula, we've got a diagram here. This is showing a line all the way across the circle. Technically speaking, there should be a dot here showing that it's going through the middle of the circle, otherwise it might not actually be a diameter. But in this case, we're assuming that it is a diameter. We're using the formula pi times d. So 3.14 times 6 centimeters. And when you do 3.14 times 6, you end up with 18.84 centimeters. Now that's what you'll have on your calculator. We are being asked to round it to 1 decimal place. So we need to do that. This is 2 decimal places. In this case, the second decimal place is a 4, so we don't have to change any of the digits. We're going to drop the 4, and we're going to say that it's 18.8 centimeters is the distance around this particular circle. Now obviously, this is not drawn to scale. This is not 6 centimeters across, so it's not real easy to visualize that that's 18.8 centimeters. Question B, we've got another circle here. We've got what looks like it's a radius. I'm going to throw a little dot in the middle there just so that I know that it's a line that goes from the outside of the circle to the center of the circle. That distance of the radius is 2 centimeters. So here we can use our other formula, 2 pi r. So 2 times 3.14 times our radius, which is 2 centimeters. So now we're doing 2 times 3.14 times 2 centimeters, and that gives us 12.56 centimeters. But again, that's to 2 decimal places. We only want 1. Now the second decimal place is a 6, which means for rounding purposes, we have to increase this 5. So it's going to be 12.6 centimeters. Now, the step that I skipped on these questions that you might want to make into a habit is to summarize the information on your diagram. In part A, for instance, we know that the diameter is equal to 6 centimeters. You might want to do that right off the start before you jump into your formulas, so then it's real clear. Okay, well my D is 6 centimeters, so we just fill it in, substitute it in that way. On this particular equation, my radius R is 2 centimeters. So then once you start filling in your formula, it's real obvious. R becomes 2 centimeters. So it's a good idea to do that. Question 3, find the area of each circle to the nearest tenth. Again, 1 decimal place. So we've got a diagram here. Again, it's showing a radius of 2 centimeters. Now, I'm dealing with area, not circumference. So my formula is different than what I did in question 2. My formula here now is pi r squared, or pi times r. So when I'm filling in my numbers for my formula, pi is 3.14. My radius, as I summarized here, was 2 centimeters. And I'm going to multiply it by the radius again. So that's what I end up with there. So now I've got 3.14 times 2, which is again 12.56 centimeters squared, but that's not 1 decimal place. So like up here with the same numbers, in fact, we're going to round that to 12.6 centimeters squared. So that's part A. Now part B, again, this is a radius of 5 centimeters. My area formula, always start with that, is pi r squared, which is equal to pi times r times r. Now I can substitute in my numbers. 3.14 times 5 centimeters. Include your units, times 5 centimeters. Then you always know what numbers you're working with. Then 3.14 times 5 centimeters times 5 centimeters. And you end up with a number of 78.5 centimeters squared. The numbers multiply to 78.5. The units, centimeters times centimeters, become centimeters squared. There's no units on pi, just so that you're aware of that. But centimeters times centimeters becomes centimeters squared, which is an area type unit, which is perfect because that's what we're calculating is the area of this particular circle. So that's calculating the area of a circle. Now, we have area formulas for some of our standard shapes. And this should be review from grade 7. We have a rectangle, and the area of a rectangle is length times width. Well, we've got a length and we have a width. We have 2 typical dimensions with a rectangle, so we just multiply those together. Area of a triangle, and this is the only one that you have to do something slightly different on out of these 3 examples. Area of a triangle is base times height divided by 2. Base is like the width or length of a rectangle. That one's easy. The height of the triangle is tricky. It's going to be typically an imaginary line. It's not from the shape itself. It needs to be a number or a line that is perpendicular, so 90 degrees to your base, that runs from the base to the farthest point of your triangle. So this imaginary line is 90 degrees to your base, and so this is your height here. It's not the side length of your triangle. It's an imaginary line. There's one exception to that, and that is if you've got a right-angled triangle, like this, where this can be your base and this can be your height. That is the only exception, triangle-wise, where it's not an imaginary line. So be conscious of that, because this is the only type of triangle where your base and your height are actually perpendicular as part of the triangle. Every other triangle, the perpendicular line to your base is going to be imaginary. So you need to be given that value, or you need to be able to calculate it in some way. Area of a parallelogram is very much like the area of a rectangle. It again is base times height. Base is typically one side of your parallelogram, but your height is going to be an imaginary line. Again, it needs to be perpendicular to your base, and it will run from the base at a 90-degree angle to get to its opposite side of the parallelogram. So in this case, it actually looks like a triangle the way it's drawn on this one, on the end of the parallelogram. So this is your base, your height is the distance between these 2 lines, not the side length of your parallelogram. So that should be a review from grade 7. So number 4, find the area of each shape. We're starting with a triangle where our area formula is base times height divided by 2. Base here And again, I'm going to summarize. My base is 9 centimeters. My height is this imaginary line, which is 6 centimeters. So base, I said, was 9 for substituting into my formula. Height is 6 centimeters. And then now I can do the math. 9 times 6 divided by 2 will give you 27 centimeters squared. Remember, centimeters times centimeters is centimeters squared. 9 times 6 is 54. Divide that by 2 gives you your 27. Part B, we've got a parallelogram. Let's summarize what we know. Well, actually, it's already done that for us nicely enough. It says our base is 10 and our height is 5.5. Usually you don't have the h equals and b equals on your diagram, so that's a bit of a gift. Base in this case was 10 centimeters. Height is 5.5 centimeters. Multiply those together, you have 55 centimeters squared. So now you have your area of your parallelogram as well. All right, next up is a math link. Please go ahead and challenge yourself on that.